And hello to everyone. Thanks for coming to this webcast. I know you could have been out having a nice lunch. You could have been attending some other webcast or generally getting something useful done on this Friday. So thanks for giving me a little bit of your time to share some of my ideas and some of my interests with you. What I've tried to put together for you today is something I'm calling a mini workshop. And I'm calling it that because whereas a lot of webinars consist of lots of slides and lots of static material, I'm going to live a little bit dangerously today, and I'm going to deliver this entire thing completely live from my web browser. And I'm hoping that this is really going to be just a better format for you as you see certain pieces of code actually running live, and as we're able to highlight different pieces of code on the screen and talk through them. Some strategic objectives, as I'll think of them for today, is to talk a little bit about data science in general and a particular analysis framework that's a 4-step process that I've been increasingly using. We'll also talk a little bit about IPython Notebook because I know some of you may have heard of it, but you may not have had the opportunity to use it yet or really understand what it is that it delivers that's so much better than just a normal Python interpreter. And of course, we'll be looking at Twitter's API, and we'll actually be running through code and talking through some of the machinations of how to run a couple of data science experiments. And so with that in mind, I'm assuming everyone can see the live screen here. That's me, you see there, and Mining the Social Web is one of the books there on the right. I've spent the better part of this year rewriting Mining the Social Web. It's a book that was originally released back in the earlier part of 2011, and since then I've collected a lot of feedback from readers and colleagues, and I've tried to be lean in the sense of lean startup in thinking about how to relaunch that book. And I've really tried to incorporate all of the feedback that I've gotten along the way. And whereas I started out with what I thought was going to be a fairly light refresh, it really turned into a rewrite. And so it's something that I've spent a tremendous amount of time and energy on, and something that I hope could be of use to you. Just to introduce it briefly, there's a website, miningthesocialweb.com. And perhaps the most useful part of this website for you initially would be the blog that you could just browse and see what's interesting. For example, there's a recent post I've put up that's fairly popular that asks this Freakonomics-inspired question, what do Tim O'Reilly, Lady Gaga, and Marissa Mayer all have in common? So that's one of the data science experiments we'll look at briefly in just a little while. But before we really get into that, let's talk just a little bit about data science and then transition into how you would get set up to actually run one of these data science experiments. So what you can hopefully see there on the screen is a Venn diagram. And you see these 3 different broad subject areas in the diagram. We have hacking skills, which would be like computer programming, math and statistical knowledge, and domain expertise, some type of substantive expertise for a domain. And when you start to think about data science, a gentleman by the name of Drew Conway, who's now I believe he's the Chief Analytics Officer for the City of New York, he originally produced this particular Venn diagram, and I think it's a great way to think about data science because it shows you that it's so interdisciplinary and it involves the fusion of a few different areas. And you can look and see that if you can hack and you have a good mathematical background, that's not too different from traditional machine learning as we know it. If you have the math and some domain expertise, that's not too different from traditional research, like operations research. If you can hack and you have a lot of expertise, he calls that a danger zone. I think of it maybe as also just being traditional software development to some degree, where you're ultimately just implementing a solution to a particular problem. But the 3 of them is pretty unique when you bring in the math and you can hack and sort of make that math a program that can learn, and you understand the domain well enough to do that for a particular end goal. So when we think about data science in general, since that's such a buzzword and it's in the title of this session, I wanted to just lead off and briefly introduce that to ground the meaning of how I'm thinking about data science for the purposes of this particular presentation to you. Back to mining the social web. From the Mining the Social Web website, you see this bar up at the top, and one of the items on the bar is this Quick Start Guide. And so really there's just a few steps in the Quick Start Guide to getting up and running. And the steps basically involve going to this GitHub repository that we'll look at in just a moment, pulling out the source code that I've put there for you. The source code is every numbered example in the book in IPython notebook format. And we'll look in a moment at why that's a really convenient format and how you can interact with that even just through the GitHub website itself. There's a Vimeo channel that I've put together and also linked here, and I'll briefly just move over to it. And as you can see, it has a number of screencasts for you, and these are designed to visually show you how to perform some of the setup that is included here on the website in the Quick Start Guide. In particular, you'll see here that I'm asking you to install a virtual machine in order to ease the experience of running these data science experiments from mining the social web, and also that's the same virtual machine that we're using as the basis of this presentation today. The reason that's so useful is because when you really want to do something with data science, you often need to tap into some libraries that are sometimes non-trivial to get installed on your environment. And so in order for me to better support everyone, and in order for me to not require you to have to know how to install certain pieces of software and do certain types of system administration and troubleshooting, what I've put together is a virtual machine that you basically download, start up, and it has everything that you need, including IPython Notebook and the scientific Python computing tools. So all those instructions are just right here, right off of the Quick Start Guide at miningthesocialweb.com. And one of those links was to the particular GitHub repository. So the nice thing about this repository is that it's designed to be a standalone open source project, a standalone collection of these IPython notebooks. And the basic premise here is explained in the README. But what you can see is that for any of these IPython notebooks, you can actually preview the entire notebook without actually downloading or installing anything. So for example, I'll just click on the Chapter 1 notebook here that I have linked, and the screen resolution will do a little cropping here, but we'll actually be working through part of this notebook in a moment, and you'll get a chance to see some of this live. You can see here we've got all of the code to do some of the things we're going to do today. So for example, how do you connect to Twitter's API? How do you hit the API to pull back trending topics? How do you start to operate on the trending topics? How do you search for things? And so on and so forth. There's another notebook that I want to show you, and let me just pull that one up. Back from the main GitHub repository. It's one of the other primary notebooks that I want to show you for today. I called it the Twitter Cookbook. So this is previously a book called 21 Recipes for Mining Twitter that I've taken and expanded and improved, and now it's built into Mining the Social Web, both the book and the code here that's maintained in this particular open source project. What it's designed to be is a collection of easily copy and pastable recipes that are very atomic and do very specific things to solve, in other words, one example sort of solves one task very easily. So here's code, you copy and paste, in order to create an API connection. Scroll on down a bit. We're back. We see things that we saw from the Chapter 1 notebook, trending topics, searching for tweets, storing responses as JSON data and or to document-oriented databases like MongoDB, collecting time series data, extracting tweet entities such as screen names and hashtags and other useful bits of metadata, and so on and so forth. And I'll just scroll on down to the bottom to show you that there are actually some recipes that do pretty sophisticated things. One in particular here, example 24, summarizes link targets. So in other words, if there's a URL in a tweet, how would you go about constructing a summary of the text for that particular web page? That involves a number of things. You have to actually pull down the web page. You have to be able to isolate the text itself. So that requires removal of the HTML and removing noise like headers and footers and margins, sidebars. But then actually, what is an analytic function you can apply just to give you back the summary of a news article? So if it's 3 paragraphs, what might be the 5 most important sentences that you could pull out of that and squash together to give you that summary? So this Twitter cookbook is designed to help you really just be able to copy and paste some code, minimally massage it together, and adapt it for any number of interesting data science experiments that I'm sure you might have yourself. So with that in mind, let's take a look at what you would see if you followed the instructions in the Quick Start Guide. It normally takes, say, a half hour to an hour, depending on your skill level and experience with installing software and following instructions, but and also internet connection, because it is going to download some fairly large files in order to get the virtual machine up and running. But once you've actually done all that, and it is easy, it's color by number, you just follow the Quick Start Guide, steps 1, 2, and 3, you will end up opening up your ordinary web browser, and what you'll see is a screen not too different from the one you see here. So we have all of the code for every chapter of Mining the Social Web organized by social web property. And, of course, this is live on your system at this point. And so what you can do is just click on any one of these notebooks. For example, I'll go ahead and just open up the Preface notebook. And this is a good opportunity to introduce IPython notebook to you in general. So if you're someone who hasn't had the opportunity to use IPython notebook yet, and you're wondering, well, what is all the hype about? Give me just a minute or two to try and explain that to you. So the really nice thing about Python as a programming language for data science is that it's an interpreted language with lots of great libraries that are many of which have been optimized to be highly performant. And it's a really nice language also for just working with text. Its string manipulation operations are wonderfully easy to work with. Python data structures in general, dictionaries, lists, and nestings thereof are very similar to JSON or JavaScript object notation, which is a common, perhaps at this time, the most common response you will get from a web server. And so if you're hitting someone's API and you're probably getting back JSON as a response, Python makes it very easy to just trivially convert that JSON structure to a native Python data structure that you can then work with. So you might get back a list of dictionaries, and every dictionary is a tweet, for example. And that tweet is just a collection of fields that you'll operate on. You'll get the time that the tweet was created, or the author of the tweet, or some other meaningful piece of metadata. And speaking of a tweet, we normally think of a tweet as just the 140 characters of text that you're limited to when you're typing into TweetDeck or Twitter.com. But there's roughly 5 kilobytes of metadata for every tweet. There's geolocation information, There's a lot of fields that have been extracted from the tweet and given to you so that you can access them very easily, such as the links, such as sources of media content, mentions of people, time, date information, author profile information. There's a number of fields, and as you're thinking about data science, try to think outside of just the 140 characters and start to think a little bit about some of these other opportunities that are there in the tweet. Back to IPython Notebook. So what is so much better? So if you have Python, and Python is this great programming language for data science, why don't you just use a Python interpreter? Why would you use IPython Notebook? My answer would really boil down to user experience, collaboration, and portability. If you are a software developer, you are comfortable working in a terminal environment, maybe you even prefer it, there may not be a reason for you to necessarily move into IPython Notebook. If you're not comfortable doing that, or you would prefer not to, all other things being equal, IPython Notebook gives you a web browser interface into that Python interpreter. So for example, I have my cursor here in what's called a cell, and you can see all this cell is really doing is printing out one line of code here, hello social web. So I'm going to move up here, I'm just going to click the play button to run the cell, and you can see that it printed out the result of the cell, and it gave me a new cell to start operating in. So you'd think, well, that's great, I can just do that in the Python interpreter, and of course you could. But think about a more complex routine and how you might go about isolating specific bits of code in that interpreter. If you're trying to isolate code as a Python developer, you may commonly comment out certain functions and rerun the script to just have the code execute that you're interested in. Here in IPython Notebook, you can literally just organize your code in a cell-by-cell structure, run each cell, debug each cell, focus on whatever each cell is doing, one cell at a time, and then string all of those cells together when you're happy with what they all do in aggregate. So from a thinking standpoint and a debugging standpoint, that could be one advantage that comes very naturally through this interface. The other is that you see here, you see all this rich text that's in the notebook in addition to this cell. The nice thing about this is that you can double click and you just open up the cell and it's editable at this point. And so this is just ordinary markdown text. You can come in here, edit the text, and it just saves the text for you. So it's as though you have this notebook of executable paper, is a phrase I've been going to. It's an intermixing of something that's pleasant to look at, that you could broadly share with others, that you could export as a web page or a PDF very easily. But you, as a data scientist or as a developer, can also execute code live in the very notebook itself. So that would be another advantage. You have portability and collaboration and just generally a pleasant environment to work with that didn't require you to get down into a terminal at all. So with that in mind, you've got this virtual machine. It's got all of this scientific computing code and collection of libraries and IPython Notebook packaged onto it. You can get that installed in literally 30 minutes, 45 minutes maybe, depending on internet connection and just how long it normally takes you to work through downloading files. And you can very easily start to explore Python as a programming language. And of course, all of the notebooks here in this collection that I have for you. So let's take a look back at the Chapter 1 notebook. One of the nice things about the Chapter 1 notebook is that I've I've tried to give you color by number instructions on how do you actually sign up with Twitter to get the credentials you need to access their API. And in addition to what I've provided you here in the notebook, which talks you through that and gives you links to click on and where to go, back in the Vimeo channel, I've actually got a video that is dedicated exclusively to that, and you can see it's about 2.5 minutes. So the steps that we're looking at here in the Chapter 1 notebook, these prerequisites before you would run example 1, you have that 2.5 minute video to walk you through those individual steps if that's something that you need. Ultimately, what that video and what those steps are going to do is show you how to create something that's called a Twitter app. So you'll have to have an ordinary Twitter account that you would normally use, but then you will create an application that will be linked to your account. And that application gives you 4 credentials. These credentials are what you see here in this particular cell. A consumer key and secret, and an OAuth token and secret. So without getting into all of the specifics, what this ultimately is designed to do is to allow you, as someone with an account, to provide some other application with access to your data and your account, but without giving it your username and password. So instead of saying, my Twitter handle is pitwobrussell and my password is 1234, I can give this application, there's actually a handshake process you would normally go through where you would give it some of this data, and there's sort of a secure process that it works through. But as a developer, as someone who's trying to really tap into your own account with your own application, you can actually just use these 4 credentials here in the cell. There's really no other way to do it. You couldn't give Twitter's API your username and password even if you wanted to. As of a couple years ago, they stopped doing that, and now this is the only way to do it. So you'll end up with these 4 credentials, and you'll ultimately end up executing this cell. And what that will do, I've previously run this cell with my real credentials here, and swap those out with something else for the purpose of this recording. But that will just print out, hey, here is an API object. It won't do anything in particular for you. But from that point on, you will see that we can use that API connection to do things that will access Twitter's API. So one thing you'd want to know about Twitter's API is that it's meticulously RESTful. You can look up REST. There's a little more to it than just an HTTP-based web API. There's sort of a style and philosophy that's hierarchical in nature and how it's designed and how you use certain parameters. And the particular library we're using here, a Python package called Twitter that's already installed with this virtual machine, or that you can install on your own if you would like with pip. The nice thing about it is that it's so minimal that it mirrors those API docs specifically. So if you look at Twitter's API docs, you'll see that there's an API called get trends for a place. So it's like get/trends/place. That is in the API docs exactly. And you can pass it a couple of parameters in the query string, one of which is ID. In here, you can read this code and you can see that it's the very same. And depending on whether you pass it an ID that corresponds to the world or an ID that corresponds to just the United States in this case, it'll bring back different sets of trends. So if I go ahead and execute that cell, and I may need to restart my notebook here in order to do that. Give me just one moment. So you see the little star here in the notebook cell. What that normally means is that the cell is executing, And normally what we would see is just that we would see that there's a set of world trends and U.S. Trends that immediately would spit out there. And since that's not happening, I'm going to reload this notebook and just check my API connection. So give me just one moment to do that. And actually, this may be a good teachable moment here in IPython Notebook for you. If you ever suspect something's going awry in your notebook, you come up here to kernel, and you can either interrupt or you can restart the kernel. So in this particular case, I'm going to restart the kernel just to be sure that everything's okay. And what that means is we're using a web browser here to work with code. But on a server, there's a Python process. And this web app user interface here in the browser takes this code, ships it back to that kernel, and that kernel executes it just as though it would be sort of running in an interpreter like normal. And then it ships the results back to us here for display. And so you see here, okay, now the cell executes. There's a number 1 here indicating that that's the first cell that's executed as part of a history. And now we'll come back and we'll re-execute this second cell. And there we have it. We have a set of results. And these results, unfortunately, aren't very easy to read, are they? This is an example of a JSON response. The first one here corresponds to the world trends. The second corresponds to trends in the United States. And depending on what's happening in the world, those two sets of trends may be different. In fact, you would expect that they would be. You can use Python's JSON module to print these results nicely so that you can read them just with one line of code like so. And now we see pretty much the same sorts of things you would see if you were on Twitter.com and you were looking at the trends box. So we see that there's Teen Awards Brazil, there's some things going on maybe in Latin America that I'm not familiar enough with to talk about. And we'll scroll on down to trends in the United States, and we see people are certainly talking about Nelson Mandela still, snow that may or may not have something to do with the weather. Looks like it might, since we also see winter here. It's finals somewhere. It's Christmas time. And so you can actually tailor these trends, of course, to be any part of the world that you'd like. So let's look at a very basic analytical operation called a set-wise intersection and say, well, what trends are happening in the United States that are actually trends in the world? What's in common there? A way you can do that is with a set-wise operation called intersection. So a set-wise intersection is just if you have two collections of things, each collection is unique, and you look at the overlap between those two, well, what's in common? So you see here, we're just literally creating sets from each of these lists of dictionaries, in this case, in Python, and we have common trends that emerge. So we see that there's only one common trend in the world and the United States right now, and it's Mary Barra. So what would you do if you wanted to get some historical data? And keep in mind that historical on Twitter could be just from a few minutes ago. We don't necessarily mean days or even longer periods of time. Twitter has a streaming API we're going to look at in just a moment that will show you how to tap into literally real-time data. But how would you collect some more context about this particular trend? Well, this particular example shows you how to do that. So I'll just come down and I'll change this query term here to be this trending topic of interest. And I won't walk you through all of the details of the code. The beauty of this is that you can sort of copy and paste it and use it really without having to worry about those details too much unless you're just very interested in them. And we'll execute the cell, and we'll pull back on the order of 100 or so statuses. And so you can start to look through the list here. By the way, an IPython notebook results will scroll like you're seeing here, and you can start to see the 5 kilobytes or so of text that exists for what you normally thought of as just 140 characters. So here we see the text, which is the 140 characters. Well, GM CEO, Mary Barra support HCCI, and split cycle engine, so on and so forth. So there's some real questions here apparently trending in the world and in the U.S. today about the CEO of GM. But you see all of these other nice things in here. You see that there's this entities node in this response that pulls out any financial symbols, any user mentions, hashtags, and URLs for you. And the URLs, of course, there's the URL that you see displayed, like the t.co links, but there's also the expanded form of that URL, and in this case, it's maybe something back to Amazon, it looks like. There's another t.co link that you wouldn't really know where that pointed to, but the expanded version of that is to authorfrank.com. So you can start to imagine, well, what domains are people frequently tweeting about for a particular trending topic? Might it be New York Times newspaper? Might it be Washington Post? You can start to think about those sorts of things and figure them out and do some interesting analysis. And really, that's what the remainder of this Chapter 1 notebook is designed to be. It's designed to be this nice, gentle introduction to Twitter. So we go on, and we won't work through every single example in this notebook because there's a couple other notebooks I'd like to show you. But we see that we continue to do some analysis, extracting text and screen names and hashtags, computing some frequency distributions, calculating some analytical functions that are mentioned in the text, lexical diversity being one of them, and ultimately even computing some histograms so that you start to get a visual idea of what's going on. So in every notebook, in every chapter of the book, I've tried to introduce an API. I've tried to think of some interesting things that you could do with the API, show you how to do that, and then provide some type of visualization just to be able to summarize some of the findings for you. And I'm going to move to one other notebook here. So back at the GitHub project, you will see here that you can download the full text of Chapter 1 and sort of get the whole scoop as a PDF, as an online ebook, or as an IPython notebook file. So the interesting thing here with this IPython notebook file is that this is the full text of Chapter 1, word for word. And again, keep in mind that what you're seeing is a bit truncated compared to what's on my screen at the moment. But you see that we have the full chapter of the book with all of the code. And so as you're working through this book, as a user experience for you, you're reading, but without having to leave the page of the book and go to some code editor to execute your code to run your data science experiment. You just execute that code in line, back to this concept of executable paper, as I've called it a little bit earlier. So you've got these Chapter 1 and Chapter 9 notebooks that are available to you. There is a nice collection of other IPython notebooks for a number of other interesting examples of data science at, I'll move my screen here to show you, It's at notebookviewer.ipython.org, and you can just Google search for Notebook Viewer and find that easily enough. And one of the collections here is a pointer back to mining the social web. And the nice thing about the Notebook Viewer is it gives you just another, really for any GitHub repository, mine or anyone else's, it gives you a nice browsable directory. So for example, there's a whole chapter on mining Facebook, and we work through the very same types of exercises. How do you get a connection? How do you start making API requests? What types of queries can you run? And eventually down toward the end of the notebook, how do you start to visualize certain things in the notebooks that you're seeing? So that's just one resource to be available, to be aware of, that is available. And a notebook that I've just published here in the past 24 or 48 hours that's out there with the rest of them is called Understanding the Reaction to Amazon Prime Air. So we remember on Cyber Monday Eve, Jeff Bezos from Amazon had a 60-minute segment, and in this he announced this experimental effort in Amazon Labs called Amazon Prime Air. And it's this idea that one day if you buy something that's fairly lightweight like a book or something that weighs less than 5 pounds, he would like to be able to ship that to you within 30 minutes through a small fleet of Amazon Prime Air drones. And so there's a YouTube video embedded in this notebook that you can watch to get the backstory on that if you've somehow missed it. And for that matter, that's a good example of another thing you can do with IPython Notebook. You can embed YouTube videos, you can embed images, really just about anything you can do in a web browser. There is a convenient way to do that with IPython Notebook. And some of the visualizations that are in some of these notebooks use JavaScript libraries like D3 to inline display an interactive visualization for you with what's under the hood. There's an iframe that's being embedded to make that happen. So the mechanism's pretty simple, but when you think of the convenience of this, well, you get to run the full gamut all the way through to visualization just right here in your web browser. I don't have the link to the video convenient here, but you can actually get to this notebook again and any of the others just through the GitHub repository or really by coming back to miningthesocialweb.com. You see here in the Quick Start Guide that there's a link to the GitHub repository, which then ultimately leads you back here where there are links to notebooks, and there's the notebook viewer as well. So I just wanted to answer that question since I see some of you are asking. So let's take a look at this particular notebook, and let's talk through some of the things that are happening in it. And one of the things that I've done in this notebook is I've already I've saved it and exported it in a format that all of the results are displayed. So in addition to seeing commentary from me and seeing code, you will see the same results as if you had executed all of the code in the notebook yourself, cell by cell. So the basic idea for this particular data science experiment and some of the others that I try to use for framing is aspire, acquire, analyze, and summarize. So in English, those words kind of roll off the tongue nicely. They're easy to remember. It's a memorable process, and I think at a basic level, it really communicates a pretty good framework for mental thinking. So let's aspire to better understand what the Twitter reaction was to Amazon and the announcement that drones may one day be delivering packages to our doorsteps. But in order to do that, we're going to have to acquire some data. And, well, what better place to acquire the data than Amazon or Twitter's firehose? So their firehose is an API. They expose it as something called the streaming API. And you can connect to the streaming API using the same Twitter library that I've previously introduced in the Twitter Cookbook and in the introductory notebook we were looking at earlier. So it's convenient for connecting to Twitter's API in all forms. I've got links throughout this notebook that point you back to Twitter's official documentation so that you can get a little more context for how it works. But the basic gist for tapping into the firehose is that you provide those same 4 credentials. You have a query that's a keyword-based query, and you authenticate, and you create this object called a Twitter stream. And you pass that Twitter stream a query, and it connects to Twitter, and data streams back to you. So you're not making repetitive requests and getting back some number of responses. You're establishing a connection, and over the network, as tweets about that keyword are noticed by Twitter as they're happening, they're streamed back to you within seconds or less of time, depending on network latency. What I would recommend as a best practice is to consider storing results from APIs in a document-oriented database like MongoDB or something comparable. But to keep this really lightweight and simple and without dragging in that complexity, I've just shown that you can take those tweets and you can just write them out to a text file that's one tweet per line. And so that's an easy format to parse. It's an easy format to slice and dice with Unix command line tools if you use those. But it's also easy to reconstruct JSON data as well. And what I did is I had some machinery already set up in order to try to catch interesting reactions. And so I had no idea the drone announcement was obviously coming. But when I heard about it, I just opened up my computer and fired off code that looks not too different from this code here and started collecting tweets from the firehose. A few hours later, I decided, well, that's probably enough, and so I stopped. And the code that you see here just takes that data. It constructs a JSON array, which you can just think of as a collection of it's the very same data as what we stored in the text file, except syntactically it's a little bit different so that it's valid JSON that a normal JSON library can now work with. And so the library that I decided to use to slice and dice the data is something called pandas. And you can think of pandas as Python for data analysis. It's a highly optimized, performant library, and the way I describe it to people is that it gives you a spreadsheet-like interface into the data. So if you imagine that basically every tweet is the same in terms of the fields that it exposes, every tweet has a created at field, every tweet has an author, every tweet has all of the same fields, and we just have a lot of tweets. So conceptually, you can cast that into a spreadsheet, right? It's just a matrix of data. Every row is a tweet, and every column is some field that's in that tweet. Well, Pandas gives you a really convenient way to express that as simply as you should be able to. And you can see here that literally one line of code, we create valid JSON. One line of code, we read the data into Pandas that we've imported here as PD, just to keep the typing a little minimally. And you can see that I had amassed about 125,000 or more tweets in a fairly short period of time from Twitter's firehose. To see what that what that data frame, as Panda calls it, looks like, where data frame here is just a two-dimensional matrix. I just print out DF, and it shows me. Here's what I've got. I've got 125,697 entries, and every one of those entries has basically these are the columns on those 125,000 rows. So if you imagine you're in a spreadsheet, you might want to slice and dice certain columns or run certain formulas on them, and that's exactly what Pandas makes easy to do for you. So there's one little caveat here. With the streaming API and all of Twitter's other APIs, there's this thing called rate limiting. The problem with rate limiting for you as someone interested in data mining and social experiments with data science is that it complicates the way in which you acquire data. So Twitter says, for your particular application that you've connected with, we're only going to allot you so many requests per time interval. So for most APIs, that's broken down into 15-minute time intervals. And every API has a different limit. So some APIs might say, well, you can make 180 requests per 15 minutes, and some APIs may give you quite a bit fewer than that. I think this is really done by Twitter to ensure that they have a reliable, stable service, and that someone doesn't try to literally pull down everything in the system, which seems perfectly reasonable. But in data mining, it does make some matters a little bit more difficult. In the Twitter Cookbook, there are a couple of recipes that make a lot of that pain go away for you, and just make a mental note to check that out if that's a pain point you've encountered or one that you do in the future. For the streaming API in particular, it's not so painful to deal with the rate limiting, because all Twitter does is that if you're ultimately about to receive more than what's 1% of the total firehose volume, they just don't give you what's beyond that 1%. Instead, they send you something called a limit notice, and that limit notice tells you how many tweets they didn't send you. So what that amounts to for our collection is that you see here, one of these columns in our spreadsheet is called limit, and we got 16 of them. So instead of getting a tweet with all the normal fields like favorited and entities and retweet status and so on, it's just a limit field that has a number in it that says we didn't send you 23 tweets. And other than that, everything looks good. So the problem with analysis here is that we have, conceptually, we have 16 rows worth of null values when we're thinking about analyzing tweets. And these null values can ultimately wreak some havoc when we're trying to iterate over data and we're not expecting to see a null value. So the first thing we want to do here is we want to remove the null values just so that we never have to really worry with them again. And let's see how many null values there were. What we end up seeing when we pull them out is that we got 16 of those limit notices, and the total amount of tweets that were limited in aggregate was just over 1,000. So in a short time period that we'll see in a moment, we got over 125,000 tweets, but we didn't get 1,000 that we could have gotten had we had some type of premium access. So that seems pretty good. We got almost all of the data that we could have wanted, more than 99% of it actually by volume. In order to do something meaningful with these tweets, we have to think about a paradigm for analysis. And one paradigm would be to think of it as time series analysis, right? We have this fire hose. It's happening in real time. It'd be interesting to look at the volumes of tweets per unit time and per time interval, and Pandas makes that really easy for us to do. We just have to first create a time index, and as you can see here, that's really just one line of code. There's a created at field from earlier that's already here somewhere. Here it is, and that's a timestamp. Twitter gives us that. It's in UTC, so it's normalized already, and we can just set an index on that in place, and we've got an index. Now we can do interesting things that are sort of Pythonic, like slice that index. So looking at the first item in the index and the last item is indicated by -1 here, we're now just slicing into our spreadsheet. So we're saying, I've got this data frame that's like a spreadsheet. I want to look at the created column, and I want to pull the first row out of the created column, where computer scientists and data scientists tend to count starting from 0, being the first row. In Python, for convenience, instead of getting the length, how many number of rows we have in this case, and using it to compute, we can just pass in a negative index. So in this case, -1 means give me the last thing. -2 would be the next to the last thing, and so on. So you can provide negative indexes as a convenience. And you see here, the first tweet that we pulled in was at about 1:41 UTC. So in the United States, depending on where you're at, that's 5, 6, 7 hours later. So this is roughly, people are winding down for the day, getting ready to go to bed, having dinner, time of the day, and it's sort of the middle of the night, of course, if you're in London or starting to get into Europe. So let's look at the volume here, and I'll try to, in the interest of making sure we have time for questions, I'll start to pick up the pace just a little bit so that we can answer as many questions as possible, and I'll be happy to stick around as long as any of you would like to talk. But as an example of something we can do here with this, look at how easy it is in this cell to just group the tweets by the hour. I've really just said I've got this time-based index. For every item in my index, I want to create this group by object, and I want it to happen on the hour. And then for simplicity, I'm just printing out a simple text-based plot here, a little histogram of how many tweets roughly are in each hour bucket, keeping in mind that we didn't start collecting till 1 hour was almost done, and our final hour we cut it off right after a minute, as luck would have it. But we can also get a lot more granular. What if we want to look at this in 15-minute intervals? Well, that could be considerably more interesting, because it'll give us a finer, more finely grained view of the data. And so you just write a custom function that looks at the minute of the hour and returns, was it 0 to 15 or 16 to 30, 31 to 45, or was it after that up to the top of the hour? And so what you can see here is that there was sort of a peak from one row to the next, but after that it generally sort of died off. So there was this initial sort of, oh my, look at this amazing announcement, everyone's talking about it, and that's gradually trickled off, possibly because it had something to do with the time of the day and people are winding down, possibly because that's sort of the way a lot of reactions tend to be. There's this really quick climactic reaction, and then it gradually subsides. In just a few lines of code here, you can also see that we can plot things. Here I've done both, just to give you an idea of something that's text-based, something that looks a little bit nicer, and of course you can invest time and make much nicer looking plots than those. Let's shift the paradigm as we kind of wrap up here and just briefly introduce some of the other things that are in this notebook. And by the way, everything that I'm telling you is documented, it's commented, and if you pull down the archive of this webcast, or you just go to the Quick Start Guide and follow along, you will have no trouble getting up and running and reproducing an experiment just like this one. But I wanted to look next at the top authors of tweets. And so I've got just a few lines of code here that pulls out the unique authors as well as a ranking of frequency for certain authors. And you can see that there's sort of a lot of bots in here. And if you start to look closer at some of these accounts, you start to see that there's a lot of accounts of Japanese origin. And what's interesting about that is that the time the announcement was made, it was roughly midday in Japan on Monday, the day of Cyber Monday. So I think it sort of makes sense that given the popularity of Twitter in Japan, you may have seen a lot of activity in that way. It may also be worth further investigation as to whether or not there are lots of Japanese bots as well. That's an experiment in and of itself. So what does it look like if you plot out the frequency of these authors? Well, I've done it a couple of ways here. One is just a frequency diagram. Another is a histogram. And you can see that it's sort of power law-esque in that there are a highly disproportionate number of authors who produce tweets with a long tail, and most people just tweeting once or maybe twice at most about it. So this is a log scale, so every jump in the scale is an order of magnitude difference. And so you can't really see the tail here in the frequency plot, but with the histogram and the log scale, you can start to get a better idea of how many tweets certain accounts produced to get an idea of the bot-like activity. Where are all these people at that are tweeting? One way you can sort of approximate that is by looking at the language that they speak. And in this case, that's just given to you as a gift in the tweet as a language code. And in one line with pandas, you can pop out a display and see that most tweets are English. Quite a few are Japanese. And then you start to see a tapering off with very few tweets being in languages in certain parts of the world here. So that's an easy thing, an easy way to get some initial insight, and it confirms what we saw earlier with most tweets being in English, but there's a lot of Japanese tweets in there as well. You can also do some natural language processing. And so in chapters 4 and 5 of Mining the Social Web, I get into that a bit. And here I've pulled in some of those tools with NLTK, a natural language processing toolkit. And as you can see, if you have a good starting template, there's not a lot to it. It's pretty straightforward how to get some initial insight. When you're doing any type of analysis, you'll typically want to start counting things right away. And so let's do that. So we've tokenized the text of tweets and cleaned them up just a little bit. And we see that Amazon, RT for retweet, drones. But you see a lot of noise here that's not so useful, like stop words, words that appear frequently but don't convey meaning, like the, to, a, on, by, is. So we can actually use some functionality from an LTK, which is a stop words list, to just filter out all those stop words and take a look at what's remaining. And here's what we're left with. So just a few lines of code, and we've removed a lot of noise here, and we see that there are lots of retweets, so there's a lot of information propagation. Of course, we queried for Amazon, so we would expect that to probably be the most common token. But if you didn't know anything else that was going on, look at how interesting it is to see that at the top of the list, drones, delivery, prime, and then air. Of course, signs of 30 and minutes not long below, giving an indication that there's some type of 30-minute delivery guarantee. And you can continue sort of working down the list. You can also look at common co-locations, which is a little more meaningful than just isolated words because phrases convey a lot more context and meaning. So if you look at commonly occurring tokens that are statistically appearing together in a disproportionate number, well, that's really a pretty easy thing to do with this library, and it shows you some common phrases: aerial vehicles, prime air, Jeff Bezos, Cyber Monday. There was a lot of talk about the Kindle Fire as well just before Cyber Monday, so you see that. And Again, you've just used a machine to analyze this human language data to provide this insight for you. You haven't done that much work to extract a ton of useful context of what's being talked about. If you kind of look down the token list here, we see words like amazing and awesome. Also somewhere in here, the word holy, H-O-L-Y appears. Here it is, holy. And so you wonder, well, what is the reaction? What are people talking about? So you can create this thing called a concordance, which is, if you're familiar with certain books like Bibles or religious texts, you'll be able to look up a word and it'll show you the context in which it appears. So that seems pretty useful to get an initial glance at what people are reacting to. And let's look at amazing and holy, since they sound interesting and emotionally charged maybe. And you see here with amazing, there's a lot of awe and amazement. You see that people are saying, I can't believe it. Look at what the future looks like. And then, of course, there's an even stronger reaction with the word holy there. One account in particular being retweeted an awful lot. That could be an interesting account to go look at as well. And of course, you can just keep going and going and going, right? You can start to look at tweet entities like hashtags and mentions. And another reaction that you end up teasing out is that you see there's a lot of mentions for a hashtag Death Star PR. And you say, well, that's interesting. What's that all about? So in addition to news sources and common accounts, you start to see some comedic accounts. And so you see that another part of the reaction was humor, right? So to sort of summarize some of the things we saw amazement, we saw humor, we saw some disbelief. And again, you've got to cut this off at some point, but you could go on and on and on and on with your analysis, and really your creativity is the only thing that's holding you back once you have the tools to do the work. So Mining the Social Web is a book that why did I spend most of the year working on it? I think it's because there's just a seriously amount of untapped creativity doing these types of things with social data. I think a lot of people are talking about it, how cool it would be if you could do X, Y, and Z data science experiments with Twitter or Facebook or LinkedIn data. I don't think too many people are actually doing it yet. And I wanted to write a book that teaches people, here's some of the theory behind it. Here are tools that I'm giving you that you just color by number, cut and paste, and then eventually make your own to get started and to be productive. Ultimately, in order to create value and extract insight from some of the most interesting data of our age. And so that's really a good place I think I'll stop and thank everyone again for their time and just answer any questions if there are any.
All right. Fantastic presentation, Matthew. Thank you so much. We do have quite a few questions, actually.
Okay.
Let's start off with Milty and Dean. They both want to know, is the virtual machine VMware or VBox, and does it run under Ubuntu?
Okay, so that's a great question. So instead of picking a particular kind of virtual machine, I've used a technology called Vagrant, V-A-G-R-A-N-T. And what Vagrant allows you to do is set up a provisioning script that says, here are all of the things I want you to do. Here are all of the commands I want run on my virtual machine. And I'm going to pick a particular provider that could be VirtualBox, could be VMware Fusion. There's experimental support for something called Docker, could be AWS, an EC2 instance. So I write this provisioning script and give it to Vagrant, and then I tell Vagrant what kind of virtual machine I want, and Vagrant takes care of the rest for me. So it's like one ring to rule them all. And what I recommend for local development is just to use VirtualBox because it's nice and easy and free. And really, you actually don't have to under the covers, the virtual machine is running Ubuntu. That's what IPython Notebook and all the libraries are served off of. But once you have that virtual machine running, you don't really ever have to interact with it. You're only working in your web browser with IPython Notebook, and conceptually, you're just running everything on your machine. It's just that this virtual machine is it's sort of tucked away and handling the dependencies that notebook experience needs. And on miningthesocialweb.com, I've got an article that you can easily find that talks a little bit more about that.
All right. And Valentine wants to know, what are the advantages of Python over R when considering data science?
I guess that's sort of maybe you're getting into religiosity really to answer, and I don't know that I'd be the best person to answer it. What I would say is that I can tell you that I know that both are very popular for data science, and I think many data scientists do work with both. Most of my background with scientific computing is with Python. Nice things about Python. One that I think is fair to say is that the syntax of reading Python is pretty close to pseudocode. It's very easy to sort of read as a programming language. There's a lot of general purpose utilities built in. It tries to make a lot of data-oriented operations as easy as they should be, and it is really a general purpose programming language. Whereas I don't know if you could say all of the same things about R, at least as a beginner. I think it may be a little bit harder to initially pick up. It's certainly more statistically oriented, more mathematically oriented. You want to run regressions. You want to plot things. That's its wheelhouse for sure. I'm not sure how much general programming you would want to do with R. I'm not sure that you would want to try to build any kind of application with R per se, as opposed to just take a data set and analyze it with R. So I think in that regard, Python would be a bit more general, and depending on your objectives, though, either one could maybe be better. And I would recommend everyone check both of them out.
Excellent. Christopher wants to know, what is the added value of the virtual machine if one already has Anaconda or Canopy already providing an extensive Python environment?
So I would say if you are a software developer and you are comfortable installing and troubleshooting installation of packages, or you have a distribution like Enthought or Canopy or whatever you may be using, you may not need to use the virtual machine. I mean, you could try to just install the packages. One advantage in a specific context, if you're working with Mining the Social Web specifically, is that I can better support you if you are using the virtual machine, because I can guarantee that all of the examples and all of the libraries are the right versions, that everything is going to work just as it should be. If you're new to data science, or you're not comfortable installing software, that really the whole point of the virtual machine is to make that pain go away. From the first edition of Mining the Social Web, I learned one of the most challenging aspects was having a book that used so many disparate pieces of technology, and ultimately having readers become frustrated because open source libraries change and API breakage happens, and different versions of different libraries don't necessarily always install the same across different platforms. So there's a portability aspect that's useful for anyone. And then I would also recommend looking at the virtues of Vagrant in general. By some people's standards, including mine, using Vagrant to create a reproducible development environment that's portable and can be shared and can easily be reset is arguably a best practice, or it's becoming one if it's if it's not really considered one quite yet. So I think those are just some things to think about.
All right. And Oksana wants to know, if you want to write a program that listens for tweets of a particular user, will I be rate limited if I poll every few minutes, and how would I overcome that rate limit?
Yeah, good question. So you would certainly you could hit rate limits if you polled too frequently. So if you asked for a user's timeline beyond the allotted number of requests that are allowed, which I think is quite generous for user timelines because that's sort of a staple in a Twitter user experience. That's certainly one way you could do it. I don't think you would have trouble with rate limits, but really I think the way you would want to do that according to best practice would be to look at the streaming API. The streaming API in the documentation, in addition to being able to filter for keywords and getting tweets about keywords, you can follow interactions for a particular user. So for lack of a better phrase, you can sort of stalk a particular Twitter user and get an update whenever that user favorites something or tweets something or engages in many other kinds of actions. So normally you would historically hit the user timeline, pull down all of the tweets, just like something like TweetDeck might do. But TweetDeck doesn't poll. It creates connections to a stream, and as interactions happen, it updates its UI to create that nice user experience for you. And I think that would be the pattern you would want to follow as well.
Excellent. Mohammed wants to know, how can we parallelize the analysis of social data, especially if we're dealing with big data, gigabytes of tweets?
You kind of broke up on me, Audra. Can you repeat that?
How can we parallelize the analysis of social data, especially if we're dealing with big data?
Yeah, well, I mean that's sort of a complicated question. I mean that's Hadoop's entire hook, is that when you're dealing with a data beyond a certain amount, you do need to parallelize it, and MapReduce being a framework that you can use to do that. Within the IPython notebook realm, one thing you might want to look at are, it's sort of a lesser known feature, but you can create clusters, or I guess you would say a cluster of machines for a notebook, and you can parallelize computation with some of the scientific Python computing libraries. For mining the social web, and certainly for the screencast today, that was out of scope. And just as a measuring stick, the 125,000 tweets or so that I analyzed in Pandas, I needed somewhere between 6 and 8 gigs of memory to really work with that, which is a pretty sizable volume of tweets. So if you were working with something on the order of, say, 1 million tweets, you might want to consider a cluster with your IPython notebook set up, or you may want to consider looking at maybe the streaming jar out of Hadoop, which can give you a Pythonic interface into MapReduce. A particular library is mrjob, M-R-J-O-B, that Yelp produced. It's a nice way to really do some easy things with MapReduce and Python. So those may be some good starting points for you.
All right. We have a few more questions here. Arthur wants to know, how can we incorporate these visuals into a website or a standalone desktop application?
The visuals. So I don't know exactly what you mean by that, but what I can say is that any of the charts that you saw in the notebook, like the histograms, the images, the frequency distributions, Those you can easily take a screen capture of, or they're actually image files that you could copy and save and download out of the notebook. And really, I guess that's the best I could answer the question based on the context. But feel free to follow up with me on Twitter or email me. My email is the same as my screen name at Gmail, so pitwobrussell@gmail, and I'd be happy to talk more about that if I didn't answer the question.
All right. And let's see here. We have another question. Is it possible to download and run one of the notebooks without the virtual environment?
Yes, you can. The trick would be that in order to do that, you would have to install IPython, which it basically gives you the ability to run IPython Notebook. So you would need to do that. That's relatively straightforward, and I believe some of the distributions of Python may make that even easier for you, depending on your comfort level with installing software. But the trickier part is that depending on which notebook you want to run, you're going to need some third-party packages, like the Twitter package I showed you, or like Pandas, or like there's literally about 25 to 30 packages I use throughout the book and throughout the notebooks. And so ultimately, to run the code, you end up needing to get those packages. You end up needing to install those packages, and some of them are going to be easier to install than others, depending on if you're using Windows, if you're using Linux, if you're using a Mac. And so I would come back to, strongly suggesting that instead of even taking that risk initially, go with the surefire thing. It really, in 30, 45 minutes, you should be able to get that virtual machine up and running, and then you don't have to worry about those 30 packages and the time that you might spend finding them and installing the right version, and what's ultimately a pretty good chance of giving you a headache. And if you want to learn about all that, then maybe you should do it. Maybe you should learn. But if you really just want to focus on a data science problem and you don't want to get bogged down in software installation and Python toolchain dependency hell, you may want to just use the VM, and as you get more comfortable or you have more time, then go ahead and sort of work in a background thread to get a local environment stood up if you're not happy with the VM for some reason.
All right, and we'll take one last question here. Could you suggest a few data flow diagrams to visualize what we're doing at any time?
A few data flow diagrams to visualize what we're doing at any time. I'm not sure if the question is asking, specific to these notebooks, or I guess in a more general sense. But what I guess the only generic answer I could offer would be there's this thing called Unified Modeling Language, or UML from software engineering, and it's a big, gnarly collection of best practices for representing software and design and architecture in many different aspects. There are a couple of types of diagrams that you can cherry pick out of that are relatively easy to use and understand and employ, without pulling in everything else that comes along with UML. And the two types of diagrams you may want to look at are state diagrams and activity diagrams. Another one would be a sequence diagram. So those are three diagramming tools, tool being sort of an abstract notion of a technique, I guess. So three different techniques you could use to diagram from slightly different points of view. And there are certainly a lot of tools out there that help you construct them. If you're using a Mac, there's a software program called Omnigraffle, OMNIGRAFFLE, that's sort of the lingua franca of diagramming. I think on Windows, a tool like Visio would probably have palettes that help you to do that, and there may even be some online web apps as well. I work on a Mac a lot of the time, and I've been very happy with Omnigraffle. So if you have that as an option, I'd highly recommend it.
All right. Thank you so much for your time, Matthew. This was a fantastic presentation and well received by the audience. I'd just like to point out to everyone again that we will have an archive ready usually within 48 hours, and that link will be emailed to you. And also we pushed out a little discount code for Matthew's book if you're interested to save 50% off the ebook or 40% off the print of Mining the Social Web. Matthew, is there anything else that you'd like to leave the audience before we end the webcast today?
The only other thing I'd say is, again, I am sincere when I say thank you for coming to this webcast. I appreciate it. I'm grateful for the opportunity to speak and to present some things that I hope are helpful to you. And I take customer service as an author incredibly seriously. And if you want to pick up a copy of Mining the Social Web, or if you just want to work with the source code, or you want to do both, if you run into any trouble at all, file an issue on GitHub, contact me on Twitter, and I'll be there for you. I'll do anything I can to help you be successful. So please just reach out if there's anything I can ever do for any of you.
Fantastic. Thank you so much again. And if we didn't get to your questions today, please feel free to tweet Matthew at his Twitter handle that is on the screen right now, and also his email address that he mentioned earlier, which is the same, but at gmail.com. So thank you all for attending, and we hope to have you at future events, and have a good morning, afternoon, or evening to wherever you all are from. Goodbye.